Welcome everybody to another Big Brain Puzzles. I am MBW, the Mega Bit Warrior, and today we are going to be doing another Big Brain Puzzle from James Kopp. It's called Golden Arrow. Timer's going. It's called Golden Arrow, and I think that this is relatively. I try to search to see like if there is. We've been doing a lot of more difficult ones, so I was like, let's see if we could do maybe a mid. So this is like a medium complexity puzzle, and let's see if medium means that it's going to take us 2 hours, or if it's actually medium and it might be good. But yeah, I'm going to go over the rules first. And if you guys have never seen this before, the link to this puzzle will be in the description of this YouTube video. So if you want to play along, if you want to pause the video, do it yourself, and then see. What is going on? Coughing, sneezing, just all of a sudden. And I didn't cough once or sneeze once until I pressed record. So that was funny. Oh my god. Okay, sorry about that. Yes, let's do the puzzle. I'm going to I was trying to see the rules, and I wanted to kind of go in there, but I don't know why I'm talking. Let's go over the rules. Normal Sudoku rules apply. So that's the digits 1 through 9 in a row, 1 through 9 in a column, and 1 through 9 in every single grid separated by those bolded lines. If you haven't played a Sudoku puzzle before, I definitely recommend doing that before playing one of these variant ones. But this one seems like it's not too bad. So no digit can appear in a chess's knight or a chess king's move away from itself. So say, for example, since the only digit that shows right here is a 1, that means that a 1 cannot be anywhere in a king's move, because the king can move 1 in chess, and then also knight's move. So let's just say like this is a 6. Let's just say oops. Let's just say that's a 6. That means in a knight's move, none of these can be 6, because that knight sees that, and so you cannot have a 6 anywhere near that. Okay. I think we understood that. And then the chess is like, if you had this, there can't be any 2 around there. Chess king, that is. Okay. Digits along the arrow, the golden arrow, to the sum to the number in the oval. So the sum of these digits equal the sum of this, or the sum of this equals this digit. So if this was like 72, that means all this added together would be 72. Definitely not spoiler alert. And the 2-digit numbers read left to right. Okay, cool. Adjacent digits along the arrow, including the oval, well, that's interesting, have a difference of at least 4. Oh. So basically, it'll be at least 4. Okay. That's a cool. I don't know why I didn't read that. I thought for some reason when I read the rules earlier, I for some reason stopped at the other part. That's a cool. Jason. Okay. So yeah. So let's just give you an example. So if there's a 9 here, it means that these 2 digits have to be at least 4 away from here. That's pretty cool. So this can't be a 6, for example, because that's going to be a 3. So it has to be a 4 away. So 5, 4, a 3, a 2, or a 1. Could be that. But same thing here. That's pretty cool. I really enjoy that. All right. So with that, we'll go ahead and get started with this puzzle. And so I'll go ahead and put the timer on the clock and let's go. All right. Obviously, we want to start here in the middle. Because the one doesn't like have any chess moves to this just yet. So 1 plus 2 plus 3 plus 4, like, all the way to 9 is 45. So just to kind of put it here, we know that it can't go more than 45. So that's why we're going to label those there. But since the sum of this is in the same grid as this one, that means, like, let's just say that this equals 20, right? That means this number would be 20. So what would be the number if you add them all together? So this would be 20. No, that's not how. Actually, the logic does not work that way. I was gonna mess up really quick. I was thinking too logical in that sense. That will not work. I was gonna say this plus this would have to be the case, but you still have to count these differently. It would be this plus this plus this plus this if we're adding everything. I was doing it as this is all one number, and that's not true. So never mind. What's interesting, though, is because we know that this is like small, this one has to be kind of larger. Like it would have to be a 5, 6, 7, 8, or 9. And then coming over here, because it has to be at least 4 away. 5 is 4 away is 9. It would have to be a 1, 2, 3, or 4. But this one, they labeled it red. But I was basically going to say it would be this as a low number. However, the 1 is seeing this, and so it would have to be there. And so then this one can't be a 5. In other words, oh wait, it can be because of the 9. Never mind. Okay, this is where it just gets complicated. Never mind. Okay. Guess not. If I was to add all these together, and the lowest that it could be is a 1, 2, 3, 4, 5, 6, and add them all together, that would be 21. So this could never be a 1. So again, that's the lowest that this can be. You know what I just thought? I think that for logic is gonna do something here. So say, for example, if this is, yeah, actually I think it will. Okay, so if this is a low number, let's just say this is low, and then this is high, and then it goes low, just keeps on doing that, right? I guess it could go 5 though. Like if this is 1 and then it goes 5, it could go high again. In other words, let's play around with this though. So for example, and we can only have one 5 in here, so that's one thing to note. So anyways, I just thought this can never be a 5 because this will... It would have to be... Never mind, I'm thinking of the logic all weird. Sorry, I'm bouncing around. Let's go here again. Sorry. Okay. If it goes high, low, high, low. Let's just say that there has to be, like, if a 5 is in here, I would still need... No, 5 is still going to be okay. I think it's the, like, basically the 9 that's going to be near the 5 that's going to be kind of giving the issues. Like, if this is 5. Actually, no. It still is going to, like, if this is 9 and this was 5, it still needs to go low over here. It's just going to, like, pause it for a second. So let's just say this then. Yeah, let's just say that this is a 5, like this one's a 5. Just to kind of get rid of the this example. Okay. If a 5 is in here, yeah, exactly. Okay. If a 5 is in here, it's either going to be accompanied by a 1 or a 9. And if it's in the middle, it's going to have the 1 and 9 next to it. So let's just say the 5 is in here. That would already be 10, 15. The lowest that this can be is 18. Very interesting. I don't know if I'm supposed to do it this way. You know what I just thought? There's 3 numbers here. It's never a 4. Because if, let's just say, like, if this was 4... Well, actually, wait. It could be... Now that I think about it. No, because this would have to be a 5. Okay, like the shortest this could be is a 5. So that's already 7, which would take it out of having all this added together. So this is never a 4. Okay. What's the highest this can be? 9 plus 8, 17, plus 7, 24, plus 6, 30. plus 6 plus 5. 41. That actually could work. Oh my god. Hold on. It's going to kind of show you. Never mind. This would have to be higher. Never mind, never mind, never mind, never mind, never mind. You know, maybe I still need to label, like, let's just say the blue is low. I'm trying to like show that like there can only be 4 lows and 4 reds. 5 is kind of a like a one that kind of toggles though, so I'm not exactly sure. Hmm. I think it has to be with something that I add here. Like adding these together, the highest I can do is a 3 plus 9, which is a 12. Oh, but if I said that this is 39, plus 12 is not, it goes way above 45. So interesting. Oh, okay. Hold on. I might be somewhere there. So again, 3 plus 9 is 12. But if it was 3 plus 9, I would have to make this all 39. And then again, plus 12. That goes above 45. Same thing with the 9. 9 plus 2, 11. This would be 29 plus 11, which is 40. So this would have to be a 5. Right here. Let's see if the 3 always has that issue. So 35 plus 8. Oh no, that could be a 2. Hmm. Huh. I thought I was picking a medium puzzle. Am I just dumb and I'm not seeing this? Like, hmm. Okay. Let's try this. If there's no 5, let's just say the 5 is here. If there's no 5, that would mean that these would have to be the high. Or they could be these ones too, but I'm just saying that these would be the highs, right? I'm going to show you guys visually so you guys can see this. I know there's one right here, but I'm just going to put it here just so you guys can see it visually. Because, again, we don't know if these numbers are actually here. But what I'm trying to say is, because we know that all of these are here and all of these are here, what's like the minimum that we can do from this? So minimally 6 plus 8 plus 7. Don't know why I said it that way, but yes. So that's 21. Minimum that we have here is like 1 plus 2 plus 3, and that's 27. But 2, 3 is here, so we would have to have a 4 instead. So let's just say it's 1 plus 2 plus 4, which is 7. So again, 21 plus 7 is 28. Except the 2's there, so let's try the 3. 1 plus 3 plus 4, which is 8. And then again, minimum is 21, so that'd be 29. That actually works. So I'll say that again. If this is a 1, 3, 4, that makes that 8. And then these ones are the minimum ones. And then this one ends up being R2, and then that one ends up being R9. Because 13 plus 8 is 21. Plus 1 is 22. Plus 3 is 25. Plus 4 is 29. So that works. I'm missing any rules. um, yeah, it's crazy. Hmm. So again, that is a solution. I just don't know if it's the solution. But like, I feel like hmm. All right. Let's go ahead and get rid of all that. I think I'm just confusing myself. I'm just going to leave that as 29 just so I can remember that. See if it is the correct version. Okay. Let me break this down a little bit. Okay, I know what 1 is going to be somewhere here. In which these two will never be 1, because if 1 was down here, king. And then if 1 was right here, the knight sees it, and plus Sudoku sees it. So these two can never be 1. So 1 has to go somewhere here. However, can there be ever a 1 here? Yes, but then 1 has to go here. Same thing as that. Interesting. Okay. Sorry, going off on a tangent. Um, okay. If this has a 6, can go near it, and 2 can go near it. Vice versa. This is a 4. It means 9 would have to go in it. And also 8. That's the only thing that can go near it, in other words. Can this ever be a 1? If this is a 1, let's just say this is a 1. That means that all these together would equal 44. Ugh. Oh, bueno, man. Wait. Oh, let me see something. Okay. So if this is a 1, where would the lows go here? We know that there's 1 here. And now we know that there's 1 here. So let's just say, to get away with it, high, low. So now we only have 1 low to go. But if we did high 5, low, but no, the 5 has to be accompanied with the 1 in order for it to actually, like, again, if 5 was supposed to be in here at all. I think that's what the logic is. If 5 is anywhere in here, let's just say it's in the middle. I'll check it in a second to see if it's anywhere else. But if the 5 was here, that means that 1 and 9 have to be here. So I can never have a 1 here because of that logic. It kind of messes me up here, though. No, this could never be a 5 because this 2, 3 has to be... Yeah. So this can never be a 5. So, yeah. Okay, for sure. You know what it was? You know what it is? I know what's messing me up. It says it's including the oval. I was treating this as like this is a separate line and then this is a separate line. This toggles like this. And I don't know why I was overcomplicating that. That makes total sense. Okay. That's the part I was missing. That took me 29 minutes to get that easy, simple thing. So I apologize about that. So I'll explain it again just because I don't know why I didn't think that this was all one continuous back and forth. I was thinking of it, in a different realm. Like basically it's like, oh yeah, it goes here and then there. Anyways. Yeah, there we go. Okay. So because this is low, this has to be high. And then when it comes here, I'm going to go ahead and put in what it can be. Again, it could be a 5. So it could be 5, 1, 2, 3, or 4. 1 sees that, so it's definitely not there. But, I at least made the logic saying that this can never be a 1. So, okay. So, that's the solution there. Because the 1 is not there, this can never be a 5. Because again, 1 can't go there. So this is indeed a low. Which makes this that again. And again, it can't Or actually, this one can be a 5. Because now this one can be a 1. But it's either going to be 1, 6, 7, 8, 9. And then this is where it gets complicated, because now it's going to go into the yeah, do I want to label it all? I don't think I do. Either way, if this was a low, let's just say that this went, instead of it going high, low, it goes high, medium. And because of the medium, yeah. Okay. 1, 2, 3, 4. Highs. 1, 2, 3. Yeah. I'm still stuck. Okay, I'm going to keep those numbers there because I know it has to be one of those. So let's just say this is a 6. Can 6 ever go? Actually, yeah. Can 6 ever go here? No. Because you'd have to have like 6 here. It would have to be the 1 and a 2. 1 and a 2. Yeah. Okay. So 6 can never go here. Because it could be a 2. And it could be a 3 also. However, this has to be a 2 or a 3. Can I do the same thing here? If this is a 6, the only option that it would give me is a 2. I can do 1 right here. Hmm. Same thing as like 4 right here. Like 4 could be 8, 9. Hmm. Maybe I can't figure that out right now. Let me try something different. Chess rules. This digit right here, cannot see this because of Sudoku. Can't see this because of the king's roll. And I can't see that because of the knight. So this digit equals this one. I don't know if I want to label that like going like, hey, this is going to be somewhere here. But like, yeah, I don't know. This one right here, let's just say it's pink. Cannot see any of these. So the pink is going to go here somewhere. Since this one couldn't be a 1, these ones have to be 1, so this can never be a 1. What did that do? Nothing. Bah. Not seeing anything else. Maybe we could do more with this. Like, okay, so King's move sees this. Sudoku sees this. Knight's move sees this. So that means this one would have to go here. I don't know why I want to. Maybe I'll just do a color. So that's there. Same kind of logic here. Sees this, sees that. So has to go here somewhere. Wait a minute. I said that the lowest that this can be is a 1, 2, 3, 4, 5. But the 2 or the 3 is not going to be in it. So that means the lowest that this can be is 1 plus 2 plus 4 plus 5 plus 6 plus 7. Okay, so 13 plus 18 plus 22, 25, 26. It's 26 plus 8. It's definitely not 45. Okay, so 26 didn't work. What about 36? That would be 9 plus 36 be already 45. So that wouldn't work. So this could never be a 6. Three, 7. Plus 37 plus 10 is 47. What about 27? 27 plus 2 plus 7. It's 36. Okay, yeah, 27 plus, sorry, 27 plus 2 plus 7. Yeah, 36. And the only way to get to that is this to have to be a 9. If 9 is right here, where would the 5 go? 5 could go here. Yeah, 5 would have to go there. Because it couldn't be anywhere else on the line, because then there would have to be a 1 and a 9 near there. But we're saying that 9 would be here, so. So it'd legit go like 5, 1, and then it keeps cycling like this. So. Starting to get tired. I haven't even got one digit. It's been like 47 minutes. It's supposed to be a medium. I suck. Oh man, do I suck. Okay. I don't know if that mattered, but. Actually, can this ever be a 2? So I already said that with the 2, 7, right? That means that would be 9 plus 2, 7, which is definitely not. Oh, wait a minute. Wait a minute. It's the 3 that I was trying to say. Okay. So 3 plus 7. Yeah, let's do that logic. So 3 plus 7 is 10. And this would be 37. So 37 plus 10. So no, that doesn't work. What about 38? Because that would be 11. And that would be over. 3 plus 9, 12. Add that to 39. 12 plus 39. That's over 45. So this can never be a 3. So this is a 2. Jesus Christ. I finally got a digit, guys. I made that way too complicated. Okay. My goodness. Okay, so I know that there's going to be a 2 somewhere here. All right, now. Is there any... I know it can't be a 1 or a 2. And it can't be a 4 if it's a 7. Yeah, I'm not sure if this is going to be... Yeah, I can't. Okay. So 2 plus 9 plus 27, that's 36. So that's the 9. What about 29 plus 29? That would make this the 5. Hmm. So this I don't think could be a 7 because the only one that it can be on these two is a 3. Any closer to that, like 4 and 5 is 3 away and 2 away. So yeah, so no 7 here. And I'm getting so tired. I thought this was gonna take like less than 40 minutes. And I'm like way above. I'm getting tired, and it's starting to affect me. Like I'm like starting to think about. I don't even know what I was thinking. I was thinking about work all of a sudden, and then I was like going through a spiel on at work, and I was like, wait a minute, I'm playing Sudoku. Like, literally, that was what was going through my mind right there. I was like, oh crap, whoops. Sorry about that. Actually, I'll put the like what options are here. So if it is a 29, this 29 plus 2 plus 9 is 40. So that means this has to be a 5. If it's an 8, so 2 plus 8, 10, plus all this, which is again 28. So plus 28 plus 10, that's 38. Get to 45, that's a 7. With the 7, again, this is 9. This would be 36, and that's where we get the 9. So the solutions are 5, 4, 7, or 9. In other words, this can never be a small. It would either be a 5, 7, or 9, which is the yellow and the red. Because I know that there's only 4 reds in here, the question is the reds here? Or is the reds here? I'm not sure. The 5. No, I can't really do anything with the 5 right now. Again, this is going to be the 5, 7, 9 up here, like this middle one. Mm. Man, I'm like not seeing. If this is a 4, it's gonna have to be the 8 nines. Wait, let me think about that again. This is the 9. Again, this would be 40. This would be the 5. I think I got it. 6. So I said 6 can't go here, right? So far. Can 6 go here? Right now, 3, 4, and 5 does not work with that. So, no. This cannot be a 6 right there. So the 6 can go here, possibly, right? If the 6 is here, what does this need to be over here? It needs to be the 7. Sorry. The 6 is here. It can't be the 7. That's what I was trying to say. It can't be the 7, 8, or 9. It would have to be the 1. Hmm. Maybe I actually need to add these things up. Let me bring a calculator. So I don't feel like doing it by hand. All right. So if this is a 7, I'm trying to signify it. If this is a 7, that means again this is 36, so then this would be 9. So, in other words, if I add all of them up, and then minus the 2, minus the 7, minus the 9, Do I get 27? I do. I feel like I already did this logic. I already did this logic. Why am I doing it again? I'm trying to think outside the box. I don't know. Leave me alone. Um, but no, that's still gonna work. No, that still works. Never mind. I can't do anything with the one, right? No king, no that. So this would be the one. This would be the one. Yeah, the one's not really doing anything for me. Um, I'm getting so tired. What am I missing, guys? If mm, Ah, wake up, Michael. Okay. La 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 la. Okay. For this to be a 1 right here. This can also be a 5. Because if this is 1, this could be 5 and then 9. 4, 8, right? And then 3. Yeah. Though I did say that the 6 needs to be there. If the 6 is there, the 6 has to be there. Because I proved that the 6 can't be here. So what's 4 away from 6? A 1 and a 2. 2 is used. So no matter where I put the 6, 6 can't go here because of the 1s. Because then both of them would have to be 1. Again, the 2 is not there. So then this has to be 6 so that this can be the 1. You know what? Maybe I'm just tired because, like, I feel like I should have picked that up, like, super quick. You know? I was gonna say this could be a 5 too, but then this one would have to be a 9 right here. So that's definitely not a 5. And because this one's not 1 anymore, that's not a 5. That's not a 7, 9 because of that. So it is the 5. And the way that this was a 5 was that this had to be 40. So, which was the 8, I want to say. The 2 8 plus 28. Man. All I'm saying is that this all has to be 40. Okay. Just think, Michael, because like it's because I'm so tired that I'm like I'm like going, and then all of a sudden I start blurring. Okay. I know I can get it because I said which one 5 was. So 2 9 29 plus 11 is 40. There it is. So it is the 9. Let me do that again. 29 plus 2 plus 9, which is 11. It's 40. And that would be the 5. Cool. So this right here, because of the 9 and the 8. Oh, we have one right here too. What I was gonna say was we do not know which one is the 4 and a 3, but now that we have this one, 7 and 4 are only 3 away. So that means 3 has to go here. All right, Jesus Christ. That took way longer than it should have, and I apologize for that. But what we do know now that we have this entire box, now we can probably fill everything in and it'd be a little bit more groovy. So this one sees this with Sudoku and it also sees this night one. So this is our one right here. All right. Uh, okay. So the 4 can't go anywhere here, so the 4 has to go here. Five is going to go somewhere there. Seven sees all this. So this is going to be the 7. So that means 3 is here. So that means 3 is somewhere here. God. It's like I'm there, and then all of a sudden I just get like a wave of tiredness hits me. Okay, sorry about that. Okay. So I don't know why. I feel like I need to like label these. 6 can't see here, can't see there either. So 6 is gonna go somewhere right here. Hmm. Oh, wait a minute. 2, 4, 5. These are a triple. Interesting. Meaning 3 definitely can't go there. So 3 has to go here. 7 has to go here. 8 has to go here. 6 has to go here. So in other words, is this a 3? Let me go through that again. So 1, 2, and again, we're trying to look for the 3. 4, 5, and then 6 gets seen right there. 7 sees that. 8 sees that, and then 9 sees that. So this is a 3. Oop. Meant to press 3. Okay. Okay. I'm getting closer here, so that's at least good. I guess I'm gonna label what these ones are. So the 6, 8, these two can't be 6 or 8. So 6, 6, 8 has to go either here. And because of that, this would be the 2, 4. Because again, I need one more place for the 6 and the 8. I know one's here, but it can't be there, so it has to be this. So that's what this is. All right, 2. This one might be a naked single. No, wait, never mind. I didn't notice the 4. Okay, let's just label things. So 2, 3, 4. 5s. 6, 7, 8, and 9. Oh, the one seeing that. My bad. Okay, so if this is 1 right here, like this is the only solution. So I'm gonna tell you how I did that. So basically, because I just noticed I was like just doing on autopilot because I'm so freaking tired. So if I talk really, like I could probably stay up. There we go. There we go. So the 1, it's seen this. This one sees this with the king. This one with the knight. So the 1 is here. In this grid, the 1 sees this with Sudoku. This one with the king. This one with the knights. So the 1s are here. So because the 1s are in here on these grids, that means it has to be on this column in this grid. But then this 1 is seeing this, so that means the 2 1s are here. Well, these 2 1s see this one by knight and this one by king. So this one is never a 1. In other words, these this would be our 1, meaning this is not our 1. So this is our 1. All that to say that. So that means this, all of them are seeing this. Yeah, I think the same thing with this. This right here is seeing everything here. So this cannot be a 1. This is seeing this with Sudoku. So this can't be a 1. Same thing with this. This can't see that, so that can't be a 1 either. So 1 has to go somewhere here, in which is seeing that. Now we have this. This 1 sees this one by king, and this one sees it by knight, so this is not a 1. 1 is here, so this is our 1. 1 seeing this by knight, so that's our 1. So this is our 1 over here. Now it's seeing all this. Again, can't be there, can't be there, can't be there, so this is a 1. This is a 1. All right, so I think we have all the 1s. Yeah, that's crazy. I feel like that's basically what you have to do on this puzzle, is just do that madness that we just did. Okay, so we know all the 6s are where they're at over here. This one in particular. So the 6s are here, right? What does that mean for this grid? Can a 6 go here? No, because it sees this by knight, or king, this one by Sudoku. Can it go here? No. King right here, knight's right here. What about here? King right here, knight's right there. So no 6s at all. No 6 also right here, because this is Sudoku and then knights. So 6s, I want to say, go here. Yeah, because if this is 6, that one could be 6 up there. This 6. I feel like I can't really say too much on that one. Okay. These two 6s, see this one for sure. See that one for sure. And see that one for sure. So that means the 6s have to go somewhere here. But these are both seeing this. So that means the 6 has to go somewhere here. And because of that, because of this, that 6 has to go here. That 6 goes away from the king, that one goes from the knight. So that means the two 6s are here. Does that get rid of anything else? Maybe this 6 right here. But that's it. Yeah, that's it. All right, the 6 goes across, sees that. This by knight, this by, or this by king, this by knight. This one can't be 6 because where would 6 go in this column or this row? Can't go here or here because, again, these two 6s see both of these. So if this is 6, this knight would see this. So that means the 2 places that it can be a 6 in this row wouldn't be possible. So this is never a 6. Okay, I think that's it with the 6s for right now. What about 7? 7 sees this. So 7. 7 again is seeing this. All right. So again, 7s can't go here. Can't be 7 here. All the other ones, it doesn't matter. So this could be 7s. Where's 8 go? 8 sees this, so 8 goes here. Yeah, because that sees that. Okay. Still getting tired. Okay. 9 is seeing this. Actually, what goes here? One sees it, 3, 4, 5, 6, 7, 8, and 9. Oh my god, it's a naked single. So it is a 2. Because again, 1 sees it, 3 sees it, 4, 5, 6, 7, 8, 9. Yep. Oh my god. That one was an easy one. I don't know what the hell. I wonder if there's any more like that, like super easy ones. Bet you there is. I'm gonna see if the same scenario happens over here. Except 3 is very... Okay, anyways. 1, 2, 3 could be it. 4 could be it. 5, 6, 7, 8, 9. So 3 or 4. Getting too tired. Yeah, 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 yeah. Tired. Yeah, 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 yeah. Finally yawned though. My God. This one. 1, 2, 3, 4, 5, 6, 7 works. 8 really depends. Fight through it, Michael. Fight through it. 1, 2, 3, 4. Yeah, I guess the 5 can go anywhere here. 6 sees that there. 7 sees that there. Both 8s are seeing this, and then 9. Oh, so it is 5. There we go. Hopefully that resolved a lot of the issues. Again, this would have to be a 2 down here. All right, 5 is seeing this, 5 is seeing that, so this is our 5. All right, 5 is here in this column. We need to, either one of the 5s is here. That would have to be a 5. 5 seeing this, 5 is here. Meaning 5 is here. 5 sees this with the knight, so this is our 5 up here. This 5 would, these two 5s would see this with the king. These 5s would see this one with the knights. So the 5 is down here because of that row as well. The 5 is down here. That means this can't be 5. This can't be 5. So let me see. I think officially I found it. This would be a 5. 5. 5. 5. Okay. I think that's all the 5s. Yeah, it is. It sure is. All right. Okay. I think I'm seeing a pattern actually now that I'm looking at it. 582, so this would be a 8 right here. 582, 582, 582, I bet you. 173, 173, 173, 173. Yeah, I bet you anything it's gonna be falling like that. I don't want to just do that just yet. So no twos here. Two would go down here. This 4 sees this, so this is a 4. That sees this. Nope. Did not mean to get rid of that. I know the 4 is right here because of the pattern, but I'm not gonna do it just yet. Again, I'm trying to do it logic-wise. 4 is right here. Again, I know it's going to be right there, but 4 is right here. 2 is seeing this with both of those, so this is our 2 right here. Meaning there can't be 2 there. 2 see that, so 2 is going to be down here. Meaning this is our 2. So 1, 2, 3, 4, 5, 6. Seven can't go there. 8. Both of those see it. And then 9, so this is a 3. I think that was an important 3, by the way. All right, 3 goes down there. All right. What should I do next? 1. So the 2. Okay. Seven, 8 is seeing all that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sees that, so this is the 4. Okay, so that gets rid of that. The 3, 7. The 4 is going to go here. 9 can go here. 7's already here, so that means 7 has to go over here. Seven. Okay, so since this row has light on numbers, I'm gonna try to focus really quick and see if I can get through this because I am tired. I'm gonna pass out right now. This is a 6 because the 6 can't go here because it's seeing that. Also, 9 was seeing that, so 9 has to go here. I think I could start like dwindling this like completely down now. So let's see if we can do it. So that finishes this row. So that's our 6. Since we saw that 6 right there, and then we said that this earlier was not 6, this is our 6 down here. So now that we have all the 6s there, that's our 6 right here. And of course our 6 right here. Let's say that's all the 6s. Yes. Okay. With 4s, kind of similar. The 4s are going to be here on this column right here, and they're both seeing this. So there's not going to be a 4 here, and there's not going to be a 4 here because of that. The 4 is going to be somewhere in this row. Spoiler alert, it's right here because of the pattern. But we're not doing that just yet. So 4 is seeing this row. That means we know that this one is a 4 right here. And then of course, since this row's taken, this has to be a 4. That sees that, so that's their 4 here. I want to say that's all the 4s. Yep. So all the ones, 2 we still need, okay. So 2. This one's our 2 right here. What are we missing? 8 and 9? Yeah, so 9 has to go down here. And 8 goes right here. Eight is seeing all that. This is the last number, so that's a 9. Okay, which one is also missing here? Sit. One, 2, 3, 4, 5, 6, 7. Oh, it is the 9. I didn't even notice that the 9 was missing. It's so funny. Okay. So 9 seeing that. Of course, that one seeing this one up here. So there's 2 9s right here. This 9 has to be because this 9 is being seen from here. So in this row. Okay, so if that's the 9, again, we saw this as a 9. This is our 9 down here. Oh, man, I'm like staring at it for so, like, I'm like so tired that like I'm like totally thinking of something completely off topic in my head, and I'm trying to talk here and I'm trying to solve, and then I'm also having like a dream right now, and that's not a good combination when you're trying to do a puzzle, because then I just start staring at it. I'm like, So that's funny, hilarious even. All right, almost done. So 7 is seeing that, so that's our 7 here. That's our 3. That's our 4. That is our 2. Boop. And then there are naked seagulls. This one is an 8. There we go. Oh my god. Again, I meant this to be a short one. And then I just totally just... It's so simple, too. The moment that I started, like, I was like, it has to be a 6, because it has to be near the 1. Like, it just, like, flowed so quickly after that. It's like I had the logic in my head, but, like, my brain was just not computing. So I apologize. But that was a fun puzzle. So I want to say thank you guys so much for watching another Big Brain Puzzles. Hopefully you guys played it, and I know if you guys did play it, you guys probably beat the heck out of me. But it was a lot of fun. Thank you guys so much for watching. Please, if you can, like this video if you liked it at all. Subscribe, and always, I always want to thank the setter for making that puzzle. That puzzle is pretty great. I know I played a James Cobb puzzle before, and he's really good. Again, there was nothing too difficult about, or like insanely difficult about this, other than I blame my tiredness. That should have been a lot easier than I made it. My big brain wasn't really braining today. But that's what happens. It's what happens. All right. I will see you guys next time for another Big Brain Puzzles. Have a good one. Bye.